What's up guys, welcome back to another video. Today I'm going to be doing a derivation video on how to derive the kinematic equations in physics. I'm going to be deriving them in two different ways, using algebra and using calculus. I'm going to start off with calculus because it's the superior one, we all know that. So yeah, to start off, firstly we need to just write the formula of acceleration, okay? And we know that acceleration is just the derivative of velocity with respect to time, you know, some small change in velocity with respect to some small change of time. And then we just need to rewrite it by solving for dv, and we do that by multiplying dt on both sides, which is gonna give us, these cancel out, and that's gonna give us dv equals a dt. Now the second thing we need to do is we need to integrate these so we can remove this part, okay? And we need, obviously this is gonna be a definite integral, and so that means we need to put in some boundaries, the boundaries of integration. So for velocity, we know that whenever you use velocity, usually you start off with some initial velocity, okay, and you end at some final velocity. So it's gonna go from some initial velocity to some final velocity. But for time, it's gonna be a little different, because you can never start at some point in time. You can never start at 3 seconds and then and then go to like 10 seconds. You always start at 0 and go to some time, okay? So we're gonna start off from 0 and we're gonna go to some time. And when we integrate these, we're gonna get the change in velocity, or v final minus v initial, equals, and this, since this is a constant, we're just gonna be adding the t. There is no, the constant acceleration is not with respect to t, with time. So we're just gonna be adding it into it. You should know integration. It sounds weird, but you need to know integration if you're watching this video. And yeah, we're gonna get this. Once we evaluate this at the boundary limits, we're gonna get this. And after that, simply enough, you just move the v initial to the other side, which is gonna give us v final equals v initial plus at. And that's the first one. Simple as that. You just solve for dv, integrate both sides, and then you get the answer. Now we go on to the next one. For the next one, we just need to do the exact same process, but we're gonna be using this, and we're gonna be doing it with velocity. So velocity is just the derivative or some small change in position with respect to time. So now we solve for dx, and that's gonna give us v dt equals dx. Again, we integrate both sides. Now, firstly, before we do anything, we're gonna write v as this, okay? So once we do that, we're gonna get the integral of vi plus at. Don't mind it, she's so adorable. Anyways, yeah, with respect to dt or time equals the integral of dx. And again, this is time, so we're gonna go from 0 to some random time. And position, again, we're gonna start off at some position, x initial, or an initial position, and we're gonna go to a final position. And again, once you integrate these, you're just gonna, this is a constant, so you're gonna add a vt to it. It's janky for a reason. Plus a t. Here we have some t dependence, so we're gonna use the reverse power rule, which gives us a t squared over t equals, then obviously this is evaluated at the boundaries, and this is just gonna give us x final minus x initial, and then you can just take out the half from this part, which is gonna give us v initial times t plus 1/2 times a t squared equals delta x. And this is the second part. Now for the last part, it's gonna take a bit longer, so I'm just gonna remove all of this. Okay, so for the final part, we're gonna basically use everything we know, everything we learned. Okay, so we do acceleration is equal to the change, this tiny change, infinitesimal change in velocity with respect to time, and then you have velocity is going to be the change in position with respect to time. And then we just solve for dt because we have both of these equal, or we have both of them have dt in them, so we can solve for it and we can set them equal to each other. Once we do that, we're going to get dt equals, on this side we're going to have dv over a, and on this side we're going to have dt equals dx over v. Okay, now we set them equal to each other. We're going to have dv over a equal to dx over v. We're going to cross multiply, and that's going to give us v dv equals a dx. We integrate both of them. So now you evaluate these two, and this is going to come out to v squared over 2 equals, and well, obviously we're going to add the things, the boundaries, and these should be simple since we already did that. And this is gonna evaluate to this, and this is gonna evaluate to this, from from the initial position to the final position, and here from the initial velocity to the final velocity. Now we add the boundaries, okay, and once we add them, we're gonna get a x initial minus, x final minus x initial, and here we're gonna get 1/2, we're gonna take out the half from here, v final squared minus v initial squared. Now we can multiply the 2 on both sides to get rid of it, and then we're gonna end up with, I'm gonna go over to here, we're gonna end up with v final squared minus v initial squared equals 2a, and this turns into delta x, and then you just move the v initial to the other side, which is gonna give us this plus 2a delta x, and this is the final one. This is how to find the kinematic equations using calculus. This is usually for people who study physics, like in college and stuff. You're probably never gonna use this in high school, but it's always nice to know this stuff. Now we move on to algebra, which is a bit more complicated than this. Now we go on to the algebra section. The algebra is useful for everyone, so I suggest you focus on it, and I'm gonna try to explain it as well as I can. the math. The behind the scenes doesn't really matter. In physics, you only care about how you solve it, not why you solve it like this. Don't take my word for it, and don't search it up. Okay, so starting off with the first one, it's very easy. You just write the formula for acceleration, which is just delta v over time. You solve for delta v, which gives you at equals delta v, and then you expand the delta v, which gives you, obviously, to solve for this, you can multiply time on both sides and then cancel out. And then here you just delta v, you can expand it to v final minus v initial equals at. You move the v initial to the other side and you're gonna get v final equals v initial plus at. And that's the first one. Now, for the second one, I need to explain something quickly. To get the average velocity, you just take 2 points, an initial velocity and a final velocity, and then you take their average by adding them up and taking 2, because you only have 2, the initial and the final. And yeah, that's it. We're gonna use this now. So we write velocity can be defined in 2 different ways, okay? By the average of the velocity, by the average of the velocity, which is v initial plus v final over 2, and by delta x over t, okay? Now we replace the v final with this, which is what we just found. And once we do that, we're gonna get v initial plus v initial plus at over 2 equals delta x over t. The v initial and the v initial add up, and you're gonna get 2vi plus at over 2 equals delta x divided by time. You can now split this up into 2vi over 2 plus at over 2. This cancels out with this. You're gonna get vi plus, and you can take out the half from here, which gets you 1/2 at equals delta x over t. Now you just multiply t on both sides, or you basically solve for delta x, and you're gonna get t times vi is just vi times t plus t times this just adds up to this t that's already here, which gets us a t squared equals delta x. And this is the second one. Now for the last one, that's where stuff gets confusing, so keep up with me. Okay, so just like calculus, we're gonna use basically everything in algebra you learned ever. No, it's gonna be a bit harder, but it's fine. Now you just, again, you solve for both time in the formula of velocity and acceleration, which is gonna get you t equals delta v over a and delta x over t. No, delta x over v. You can do the math by yourself. I just did it already. I did it again. And once you do that, you're just gonna cross multiply here, and that's gonna give you v delta v equals a delta x. Now here we can expand both of these to their original forms. If you remember, this is gonna go back to the first kinematic equation, and you're gonna get v initial plus at. No, this is gonna be v initial final minus v initial, and this is gonna be the average velocity, which is v final plus v initial over 2 equals a delta x. Now you can multiply 2 on both sides and you can get rid of this, which is going to leave you with v final minus v initial times v final plus v initial equals 2a delta x. And then you just use the FOIL method on this, which is going to give you v final squared. Then you're going to get plus v final times v initial minus v final times v initial minus v initial squared equals 2a delta x. This and this cancel out, which gives you v final minus v initial squared equals 2a delta x. And finally, you move the v initial to the other side, which gives you v final squared equals v initial minus plus 2a delta x. And that's the final kinematic equation. I hope you enjoyed this. I hope the explanation was good enough. Use this if you ever forget the kinematic equations, and I'll see you in the next one. Goodbye.